How much data do you think that little wafer can hold anyway?
More than they look like they'd hold, Smarty. Up to 2 megabytes.
Huh? 2 megabytes? In that?
Hello and welcome to another video from Flash Jazz Cat. And in this video, as you can see, we've got a pair of Atari SF314 disk drives on the desk. And what on earth are we going to do with these? You might also notice on the desk here, I'll just pull this board out and let you have a little look. So what we've got here is this board called the SF551, and as you can see it's by DropCheck, and this is revision 2 2019. Now this is a drop-in replacement logic board for the SF314. Now the actual SF314, as it comes from the factory, doesn't have a great deal of logic in it at all. So logic board probably isn't the right word. Probably the better word for it is just PCB. And speaking of PCBs, I think it's time for a message from our sponsor.
If I want to prototype PCB making, I always go to PCBWay.com. It's the best. They do the best prototype PCBs and they've been doing it for 8 years. You should go there too. You can't go wrong because they're experienced and they produced excellent high quality PCB prototypes. They offer all kinds of other services including CNC machining and even 3D printing. So why not show me your capabilities by visiting PCBWay today? Come on, do it now.
Okay, so the PCB in the SF314 is really no more than a couple of I/O jacks on the back. I've took the power switch off this one actually because I needed to cannibalize it, because all the drive control logic, the actual floppy control chip on the actual floppy controller is actually on the ST itself, on the ST motherboard. But we're not going to use these drives with the ST. They never come with data cables and power supplies, these drives. And as I've discovered today, and I'll show you a little bit later on, there's lots of different variations of these drives. They all use the same DIN 14 data cable that plugs in the back of the ST, and these are just unobtainium, these connectors now, the actual cables. But they use various different kinds of power jacks. Certainly there's DIN 7 female jack, and there's a male DIN 5. I'll get into that later on. But anyway, the idea was that we take this board here, which DropCheck Lenore at Bits of the Past kindly designed after somebody came up with the idea of wanting to try and use an Atari ST external floppy drive, which are the kind of, for the reasons that I've already explained, the lack of cables, different power supplies, and they've been replaced by things like Gore-Tex and whatnot. They're pretty much next to useless now, these things. Very few people use them. And it would be a nice way to repurpose one of these drives, actually use it as a floppy drive on an 8-bit Atari. So the idea was that this board here would fit more or less into the same footprint as the original board in this drive, but it would actually provide drive logic, controller chip, etc., which of course the Atari 8-bit doesn't have on board. The Atari 8-bit requires peripherals to be intelligent, if you like. So that's what she did, and she designed this board. Now I've been sent 2 of these boards and 2 drives, 2 pretty much new or new old stock drive. This one's still got the protective film on the badge. The one underneath it hasn't actually. But these came from Best Electronics, and they still, until I opened them up, this still had the anti-tamper warranty stickers on the bottom. So I was sent the drives, the boards, some cable stuff, and all the bits, the entire bill of materials to populate the board. There are a couple of bits actually, but this is where the problems began, that you need to salvage from the original board. This is the original PCB from these particular drives. They're both the same and identical drives, and as I say, this particular revision has a female DIN 7 power jack, and one common mode choke on the board because there's only one reel. The whole mechanism, I think this is the later revision of the SF314, and that floppy drive works on 5 volts. So the power supply provides 5 volts. I think these would actually run off an XE power supply anyway. But yes, that does go in there, so we could, if we had stuck with the original DIN connector, of course, I'll get to that in a minute as well. So if we'd stuck to the original DIN connector when doing this conversion, we could have actually plugged the resulting disk drive into a standard Atari XLEC power supply, but we didn't do that. That's not how it's been done, but there's probably, well, there are apparent reasons for that anyway. Anyway, drop check suggests that you salvage the power button from the original board, which we've done. So obviously I've already started this one, and I didn't want to go through the entire thing with you watching me put resistors and caps and transistors into a board, but I'll finish it in this video. So we've got the power switch, which we've salvaged from the other board. We've got the common mode chokes. So one's for the 5 volt rail and one is for the 12 volt rail. Well, why 12 volts, you ask? Because I thought you said the drive worked off 5 volts. Well, now there's different revisions of the SF314, and I've got one of the older revisions right here. This is my drive, which I never used. It was in the spares bin, and thank God I had it because it kind of saved the day today. It's completely different inside. If we have a look inside the two different drives. So this is the older revision, SF314. Now, what you can see about this one, now this was the one that I had lying around in the spares box. I've also took parts off this one as well. So the 2 chokes and the power switch and the power jack. The board sits upside down in the back of this revision of the drive. And before I took the power connector off, this one doesn't have a DIN 7 female power connector. This one has got a male DIN 5. Actually, it's a modified DIN 7, as you can see. There's got some holes where the extra 2 pins would go. But anyway, this is the power jack that was on this board, and the board is upside down. Now, this is where I started to get confused this afternoon, because it was obvious that Lenore, when she designed the logic board, I thought, well, obviously so here's the board, here's the drive with the DIN 7 in the back. I thought, well, obviously it's not intended for this version of the drive, because this version has a DIN 7 at the back. And Lenore's board, very clearly, there's the power connector here. It's very obvious that Lenore's board does not use a DIN 7, a female DIN 7 power input connector. It clearly uses this one, which is the DIN 5, because that actually it's an unusual connector, because the strain relief is actually a clip, and it clips around the edge of the board like that, and that'll sit in there like that. So when I was realised that obviously I had to salvage the common mode chokes and the power connector from the old boards, well, there was a problem, because we've got 2 drives to make here, and each drive that I was sent only had 1 choke on it and the wrong power connector. So we had a problem. Anyway, fortunately I was able to drag my spare drive out of the cupboard, as I've said, and that drive happened to have this connector on it, but the circuit board is upside down, and there's no way on earth that this circuit board will go into the drive upside down. So I thought, which version of the drive is it actually designed for? But anyway, when the fog cleared, I realised that yes, indeed, this board does fit perfectly in the drives that I was sent, and it fits the right way up as well. But obviously the drive that Lenore used when she designed this board was somewhere between the two. It obviously didn't have a DIN 7 connector for power. It obviously had this one, but it also had a board that sat the right way up. So there must be a third revision. Obviously has 2 common mode chokes, a 5 volt rail and a 12 volt rail, and one of these connectors on it, and a board that sits the right way up. So it's neither of these two. So I was able to take the power connector from my spare drive, 2 common mode chokes from my spare drive, and with the 2 common mode chokes that were on the 2 drives that I was sent from America, each of which had 1 common mode choke, that gives us 4 common mode chokes, which is enough to populate both of these boards. Not that actually both of them will be used, because the mechanisms on these more modern revisions of the drive actually run on 5 volts, and the reason we know that, as we've already seen, is because this power connector is compatible with the Atari XLXE power supply, which only provides 5 volts. So what we're going to end up with at the end of the day is this power connector on the board, but with the 12 volt supply not wired up at all. So we'll be able to use any old 5 volt DC power adapter, but we just won't wire up the 12 volts. Now, I've spoke to Lenore about this, and she says it's going to be no problem. So we'll just have 5 volts coming in here. One of these common mode chokes will be totally inactive because there'll be no 12 volts going through it. The other one will have a 5 volt supply, and everything should just work.
You serious?
And this board definitely fits in this shell. So we've got what we want from this drive, so we can put this out of the way now. And of course, since we're going to have custom made power supplies for these things, I also needed a female DIN 5 connector to plug into these, so this will get taken off and wired up to one of those Cisco power supplies or something. And I had 2 of these. These are actually from Super Color CPU cards, and I'm sure I've got another one lying around. Because I never used these connectors, I wired them on the 800 straight up to the monitor jack. So I thought, and Jürgen sent me a second board as well, which was very, very kind of him. And so fortunately I've got 2 of these. Now for the I/O connectors, Lenore, instead of using those impossible to find DIN 14 connectors, she's used the much smaller DIN 13 connectors here. So there's two of them going to go on the board. So obviously we need data cables, and the data cables are going to have a DIN 13 connector on one end and a standard SIO connector on the other. So this cable here, how long it is, about 3 feet. So this is going to be chopped in half, or I might have another one lying around somewhere. May make longer cables if we've actually got a spare one. With a DIN 13 on the other end, so I get to solder up DIN 13 cables, and also have to make custom power supply cable as well. But yes, other than that, it should be pretty much plain sailing from this point. Let's go ahead and finish building this first board. Right, so I'm going to use sockets, nice precision sockets on these as well. I think it deserves it, why not? Slight problem here is that the strain relief pins on the DIN 13, if you can see that, I haven't got anything to solder to. There's no pad around there. There should be a pad that attaches to the ground pad, but there isn't. So this connector is not going to be very, very strong. I wonder if there's anything we can do about that. What I suppose I can do is solder a bar across the bottom here. Yes, I'll scrape away the solder mask there, and that's what I'll do. We've got the same problem here as well. There's missing plate through on the strain relief on the power switch as well. So there's a few little errors remaining on this board, but we can work around it. It's the power switch I'm particularly worried about, because that doesn't really get its strength from the connections at the back. It gets its strength from being attached to this, so I'm going to have to do something similar, scrape away the solder mask on there and bodge together some sort of fixing method to keep that switch from moving around. Okay, it's really starting to take shape now, really starting to look like a disk drive, a logic board. Okay, so we're going to need those jumpers attached now, which have helpfully been provided here, indicating the 8050 CPU, and we'll just stick this on OS 1 for the moment. The power output for the drive, whether I'm going to solder the cable directly to the board or rig up some sort of connector. I mean, I could solder it straight to the board, I suppose. I don't know. The originals do. The originals have the power going straight into the board. It's going to be very, very tight squeeze, mind you. So this is going to sit like this, and you can see that the back of the power connector of the floppy drive is right smack up against the drive controller. But other than that, it all looks okay. It looks really good, actually. So there we are, one completed board basically, minus the EPROM and the power connector for the floppy drive mechanism. So I might as well get the worst job out of the way first, I suppose. Now I need to solder a DIN 13 cable onto the end of an SIO cable. Alright, so I did some off-camera work last night, and because watching me trying to solder a DIN 13 connector through a magnifying glass probably isn't going to be particularly entertaining. For the moment I did chop that SIO cable in half. It's not very long, but I don't think it's going to need to be. And the fortunate thing about this was that I only had to make 4 connections really. Command, data in, data out, and ground. So that's all I've wired up here, because that's all this is going to actually use. So hopefully this will work. So with that done, just for quickness, now I'm going to redo, because in the kit of parts there was a nice roll of ribbon cable here, but I didn't much care for the grey connectors here, and there was no edge connector for the drive end as far as I could tell, and I don't have any of that particular size, 34 way. So this is just the ribbon cable from the drive as it came, and I've put that connector on this end. I forgot to put the strain relief on, needless to say, but anyway, that'll plug in here like so. So that's the drive data cable. What else? Well, we've got the power. Now I haven't got, also not included, they were crossed off on the bill of materials. There was no little Molex 4-pin connector. You normally see like a white one. Now the original boards didn't have them on, and it's hardly essential, but the floppy drive cable that was provided, the wires are so thick they wouldn't go straight into the board. So I've just had to use the original cable from my drive, which had a funny lip on the bottom of it, which I've cut off, because the wiring on that one is ideal for this. So I've just soldered that straight to the board. Other points of interest. Now I believe this is the drive controller chip here, and I believe that one is, as Candle said to me last night, the AtariAge chip. This is the 8050 processor, and this spot here is where we're going to put our EPROM with dual operating systems on it. So that's basically all I've done in the meantime. What I will do now is we'll sort out the strain relief on these connectors. I sent Lenovo a message last night, and I just said the only thing I've noticed on this board that I would consider a fault is just the lack of plate on these through holes here. So we'll do that now before I forget. And then I'm going to have to make a power supply. Now the connector here, I've got one of these on order. This connector here is very, very unusual indeed. As you can see, it clips over the edge of the board. So that's what provides the strain relief there. It clips over and then it pushes in, and it's a 5-way connector. But you can see, if you can see there's 2 holes at the top. So this is also it's a kind of at one point in its life, or its design history, it was also a DIN 7 connector. Now I hunted around for about an hour and a half yesterday afternoon trying to find one of these because we need another one for the other board, and I haven't got another one. And where I eventually found it, I'll show you on the screen, was a retro computer parts supplier, and they sell this. It was about £10, mind you, but they sell this as a DIN 7 connector, and this is actually the power connector that was used on the original 260 ST computer. So obviously I've ordered one of those, and it'll be a fairly simple matter to cut the two contacts. There you can see the holes for the extra two contacts at the top. Cut them off from the back, pull the pins off, and then yank the two extra pins out from the front there. If I hadn't been able to find that one, I don't know what I would have done, because this board is specifically designed for this specific connector. And the best I can do is a DIN 7, and it's the correct part because this is basically a DIN 7 with two missing pins on it. So what I'm going to do is I'm going to scrape the solder mask off between these two pins here in a straight line. And so I'm going to just scrape in a straight line across there between the two pins. Same thing here, and we'll do the same thing here. We'll do it across this way diagonally. We need 4 of them. There we go. I'll put a little bit of flux on there, just a tiny bit. There we go. Tin these as well. Grab that. Okay, that looks about right. So they've got now continuity to ground on the bottom there. Do what they need to do, because that's also going to be a shield. Okay, looks fine. Okay, so I think that looks reasonably neat, and now we've got some additional strength at the front of the connector, and on the power switch it's impossible to move it, so it's an improvement. Right, so finally the power supply. So I'm going to have to make it using a female DIN 5, which, as I said, I had lying around. Fortunately I've got 2 of them, so that's going to push into here like so. So we just want the center wire on the 5V pin, which is going to be the outer left pin as far as I can tell. I'll check with a multimeter, and it is. So we just want 5V on that left pin. We'll stick the ground on the middle one. This is not intended to be neat, tidy, resilient, anything at all. I just put the thing on. I'll come back to it later on and tidy it up. I'll come back to it later. I'm going to put some proper insulation on it and everything. Right, so there's our power supply, and that is going to plug in here like so. So I've pulled out a selection of EPROMs here. And I've got my Mini Pro programmer here. Now I'm assuming that the size won't matter here, and that the pinout's going to be the same for all of these EPROMs, so that's going to sit in the socket there. So what I'm going to try doing is programming to this the stock ROM and the HyperXF ROM, I think. Right, so I've got my TL866 here. I've got an EPROM that looks like it's blank. It's a 27C5112, so it's a 64K. So what I'm going to do, I'm not even bothered about switching between different ROMs at the moment. So what I'm going to do is I'm just going to concatenate this ROM on top of itself repeatedly. So I'll make that, and I'll select all of it. So we're going to use HXD here. Just going to select all, copy, right, so that's done it. Yep, that's correct. Then we'll select all again, copy again, paste, insert. It's a long time since I've used EPROMs, and I used to have lots of problems trying to get them to program, but with older flashes. But the TL866 is pretty good. So if we do a read back now, hopefully it will show that it programmed. And it looks like it did. Okay, pop the chip out here. Oh, I will show you actually while I'm about it a couple of other things that I've done here, because I couldn't get the thing. The thing is an incredibly tight squeeze with this longer later, because this is a standard, more or less a standard 3.5-inch mechanism. It's much longer than the older drive, so this is a real tight squeeze to get this board in at all. I did have to redo this cable because it wouldn't actually reach from point A to point B there, so I have made a new cable, but I'm wishing I brought the thing in from the top rather than the bottom, because it's tending to block on this transistor here. But never mind, I think it's a transistor. Yeah, it's a transistor. But I've bent that down a little bit, and likewise the power connector for the drive is right up against the controller chip here. It is a very, very tight squeeze indeed. But anyway, let's put the EPROM in. I'm not going to put tape over it yet. I know. It's going to work long enough to find out whether the damn thing works or not. The other thing I did, the DIN 13 connectors that were supplied, they had ground shield plating around the outside, around the connector. Not only did that make the DIN connectors very, very difficult to push in, and it looked bad because these DIN 13 connectors sit in holes that are far bigger than they need to be, because they of course were for the bigger DIN 14 connectors. So at least all you see now with that silver shield removed is just like a black void. So that's better. So I think what we'll do, oh, this is the scary bit. We'll do a power on test. 5 volts, there we go. So we've got power. We just don't have any motor activity for some reason. We've got a light. Let's pop a disc in. And it spins. Oh God, it sounds a bit. Okay, so it actually spins the drive. Let's try and set it up with a computer. Have we got a drive? So let's go in here and start at OS on. Let's have high speed SIO. Let's quit. Cool. Turn the drive on. Right, so the situation we've got here with this drive is quite interesting. I seem to remember, because I converted an SF551 to 3.5-inch mechanism, and I remember when I turn the drive on, the motor spins up briefly. I think it does a seek, I can't remember offhand. It's that long since I've used a disk drive, but so anyway, when I turn this one on, it does indeed start up and it spins a bit, which seems normal. Now it's got 2 dip switches on the back here. Now of course they select the drive number to which the unit's going to respond over the SIO bus. Now normally both these dip switches are in the down position to signify drive 1. Now I've got them both in the up position. And when they're both in the up position, I turn the drive on and it spins up. Now if I put both jumpers in the down position, which would be the normal dip switch position for drive 1, and then I turn the unit on, nothing happens. There's no motor activity at all whatsoever, and I can't see what possible connection this could have with the drive motor and the controller, because the sole purpose of this dip switch here, or these dip switches, is on the SIO side of things, not the disk drive side of things. You would think that when the power is applied, regardless of what these dip switch settings are, the drive would go through its normal startup procedure. So it's very, very strange indeed. I don't understand what's going on there. This is a jumper to select between two different variants of CPU or MCU, so the Intel 8050 and 8040. Now these particular MCUs are 8050s. I did, just out of interest, try swapping the jumper over at one point. I have tried it in both positions and it didn't make any difference. So I don't think that's the problem. We've got power. Now I have been in touch with Lenore about this, because it's been quite a few days now since I finished this logic board, and I've been unable to get it to work at all. It's absolutely stone dead. I mean, if I turn it on here and try and get some sort of response out of it, absolutely nothing. It's as if nothing's connected to the SIO bus at all, and it doesn't matter what position the dip switches are in. I'm assuming that both up would actually be drive 4 anyway. It does spin up when I turn it on with that configuration, but once again, even if I do a DIR or drive 4, nothing at all. So it's very, very puzzling indeed. Lenore, very, very kindly and very quickly, she's been super, super helpful. She was asked all the right questions, all the right things to check, which I did check already, but she did send a care package over here. Now, one thing Lenore did point out is that the crystal that I was sent, or the crystals that were sent for both drives, were actually 8 megahertz crystals. Now that's on the schematic, which Lenore also kindly sent over, and it's also on the bill of materials. But she said that the proper value, and I've verified this by checking an SF551 board, is 8.333 megahertz. And asked her, is this really important? Why was 8 megahertz specified on the bill of materials? And it seems like you can use either, but she said that a few people had reported problems with the Hyper OS ROM, which is what we've got here, with an 8 megahertz crystal. And the 8 megahertz crystals are far easier to get hold of, these being rather rarer. So what Lenore very, very kindly did, and I can't thank her enough for this, is she sent me two 8.33 megahertz crystals. She sent me another couple of MCUs. She sent me two WD-1772 drive controllers, and she sent me a couple of EPROMs as well. The owner of these, or the person who commissioned these drive conversions, sent me several MCUs anyway, so I don't think that's the problem. He sent me two AJAX chips, which are the drive controller chips here. I've swapped these out, changing the processor, changing the controller chip. Doesn't make any difference. I've tried the EPROMs. That didn't make any difference. So I'm really, really puzzled. I've been all over the board. I've checked out the schematic and everything, and I can't seem to see what the problem is. It doesn't matter what I do. I even tried connecting the computer to the the auxiliary SIO bus here, just in case there was some confusion over data in and data out. That didn't help either. So nothing I do seems to make any difference here, and it's very, very puzzling indeed. So I don't know what to do next. Right, well, since we've got an oscilloscope here, I think the first thing we should check is that we get commands sent from the command line on the SIO bus. So I'm going to do another DIR command here and just see what we get. And there we are, we can see command packets coming across to the command pin. So it's reaching the machine. So let's also check, I think it's pin 6. Let's see if we get commands going as far as pin 6 of the MCU. And we don't. That's bizarre. So the command signal is coming to the command pin here. I'm sure I've got the right pin. Right, so I'm on pin 6 of the CPU, which is where command attaches, and we get nothing at all. That's weird. Right, so somewhere in this little maze of transistors and resistors here, the signal appears to be getting lost. Now, as I said, Lenore was kind enough to send the schematic, and I've been all over this circuit I've checked the transistors, I've checked the orientation of the transistors in case they didn't match the silkscreen or the silkscreen was wrong. Everything checks out, so I don't understand why the command signal isn't getting to the MCU. I've checked that the MCU isn't in a reset state either, and it's not. Because that's active low and the reset pin is high. So the CPU isn't in the reset state. The command signal gets here, and yet pin 6 is just flat as a pancake. So I'm really puzzled. So what I think we'll do now is we'll check some of the address lines and the data lines on the EPROM and see if there's any signs of life. We should get activity. I'm just randomly testing pins on the EPROM here because the operating system should be running all the time, watching the SIO bus. And there's nothing. That seems a bit strange. I think pin 13 is an address line. So the operating system on the board isn't even running. No wonder we get no activity. So why... I'm going to check that reset pin again. And it's high. So the chip isn't in a reset state. It's powered up, it's got power. We know the drive's got power. Ugh, why doesn't it work? We know it's not a dead CPU, and we know the drive controller is good. We've swapped that out multiple times. I'm just going to try swapping that jumper again, I think, and see what happens. So I'll put that in drive, I'll put the jumpers in drive 1 position again, and just see if moving the jumper to the wrong position gives us any activity on the address bus. Now what happened there when I turned it on? I just get a tiny little jolt from the motor when I turn it on with the jumper in the wrong position. I don't expect this to work, of course, because this is for the 8040 CPU and we've got an 8050 CPU in here. So let's have a look at what we've got. What's this? Oh. Hang on a minute. So the thing's running now. What? So it's reading the EPROM. The EPROM, of course, has got the operating system on it. It's reading instructions from the ROM with the jumper in the wrong position. But I tried this before and it didn't work. Right, let's try again. What? How come it suddenly works? I tried this different jumper position before and it didn't work before. I can't believe this, how it suddenly works with the jumper in the wrong position. So presumably the silk screen for the CPU type jumper is back to front. There we go, disk directory. That's unbelievable. Let's try and format the disk just to be sure. We'll do 80 tracks double-sided, 720p. Here we go. That's formatting. The only problem here is because we're using a proprietary SIO connector on the back of the drive, because there isn't room for a full-size SIO connector. It's very difficult to daisy chain anything in here, so I'm just gonna... Right, so I'm gonna make myself a test file here. We're gonna just copy a file from the car device on Sparta-DOS X to the disk. Right, we appear to have a file. Yes, we do. Now let's copy that file to another file. Call it back. Pretty quick. Of course, we formatted this disk with ultra speed skew as well, which the operating system on here supports. So it's a bit hard to tell what actually happened here. When I've tried that other jumper position, just to see if, on the very slim off chance that it was mislabeled, which it turns out it is, there must have been some secondary problem that was preventing the thing from working still. It can't have been the data in and data out lines being reversed, but what I do notice here, which was confusing for a while, is the data in doesn't mean data into the disk drive, it means the data in line on the computer. I would have expected data out to go to data in on the computer and data in on here to go to data out on the computer, but it transpires that's not the case. But anyway, that would have given me a completely different kind of error, error 138, which just basically no device. So it can't have been that. It can't have been the dip switches, because I knew even though Lenore said she might have got the positions wrong with the dip switches, that I had a look at the schematic and it was clearly not the case. Now all I can think here is that the one time I did try putting the jumper in the wrong position is that I simultaneously had a problem with the EPROM. I've tried several different EPROMs in this board, and maybe because this is a 27C64, maybe the 27C128 chip, which is a 32K EPROM, which should work in here because it's got a jumper to select between two operating systems. Maybe that didn't work. And that was basically giving the same error when I had the jumper in what turns out to be the correct position. But now I just happen to have the right EPROM in, and I happen to have tried that jumper in the other position just to try and establish why there was no bus activity on the thing whatsoever, and now it works. Now unfortunately that's not the end of the matter, because of course I've got two drives to build, and one of them from this drive here, the mechanism, well both mechanisms on the two drives that were outwardly identical, as you saw. Neither of the drive mechanisms were particularly in good working order. I had a lot of trouble getting particularly this one to format anything. And I had to go through a huge box of discs actually to try and establish, well, firstly whether I had any decent discs, and there weren't many, but I managed to isolate 18 discs that formatted. So I went through a box of about 70 discs trying to format them all. Both drives had to be stripped down because of course they've sat in a warehouse for about 35 years presumably, and hadn't really been used, these being new old stock drives. Now some of the lubricant that they obviously put on this worm drive, I think it's called, and for the stepper motor, and the eject mechanism, and of course the rail along which the head moves, a lot of that had actually solidified, and it was doing the opposite to what it was supposed to do, which was to ease movement of moving parts in the drive. So I had to basically strip both drives down and re-lubricate everything, clean everything. They weren't too dirty, it wasn't so much dirt, it was mainly the kind of the grease that had just solidified. Anyway, the second time that I went into this one, this is because both mechanisms in the drives were completely different. The other one's a Sony, this one is Mitsumi, I'm assuming that's the name of the motor manufacturer. Now this drive is, as I say, a completely different design, and it's a bit more difficult to get the cradle out, so I didn't bother at first, and it still wasn't formatting discs that I knew to be good, tested in the SF551. The SF551's kind of the benchmark because that one I know works. So I had a second go at taking this one apart. Now this drive has a particularly stupid design. If you look here, there is a push fit connector which has to be removed, and this goes straight to the read-write head. So before you lift this board away from the top, you have to disconnect that connector, and I knew that and I managed to do it the first time round. But the second time I took it apart to try and tear deeper into the mechanism, this flex cable just snapped in half, unfortunately. So that, and of course that goes straight to the read-write head. So There you go, that's supposed to be connected there. Probably hotbarred to the back of the read-write head, so that basically this drive then became trash, unfortunately, so which put me in a bit of a blind panic, because of course I'm intending to keep one of these drives and the customer gets the other one. That's the fee we agreed for doing this job. So we had a big problem here. So what I had to do was dig out another drive. And the drive that I dug out, I've put it way back in the box now. It was a Sony mechanism. It was very much like the other Sony mechanism in the other drive, and I thought this is going to be fine. That one didn't work properly anyway. I reconditioned and refurbished that one and got it to format discs and read discs. Everything looked great until such time as I came to put the fascia on, because as you can see here, Atari in their wisdom decided to use a completely different proprietary design for the fascia and the eject button on the drive. So I presume the manufacturers that they bought these drives from obviously made provision for this with proper mount points and a projection at the front of the eject button. So this is what I'm talking about right here, that this eject button is completely non-standard positioning for the eject button to slide on here. No stock drive has the eject button like that. It's usually further to the left. I couldn't get the eject button on to fit, and I thought this is becoming a serious kind of engineering sort of issue here, and I couldn't really get the drive fascia to fit the front of the other Sony drive in the way it obviously fits this one perfectly. So I was completely exasperated. So what I did in complete desperation with this drive here was to pull an Atari ST out of the cupboard and take the drive out of that one, and fortunately it had exactly this fascia, because there was a couple of different designs for the drives in the Atari STs, as indeed there are for these drives. Fortunately, the first machine I pulled out from the corner of the room had exactly this kind of design on the front, so it was going to fit, and it was going to fit the eject button as well. Although this is actually the fascia and the eject button from the Atari, not from the drive. But of course the drive that ended up going in here when it came out of the ST was absolutely packed full of dust. It was in an appallingly bad condition. So I had to recondition that mechanism as well, and of course got it working, fortunately, and that is now in this one here, and it does work, as they both do. Oh, right, so having actually got the drive to format, I did encounter an additional issue. This drive, this is the other one which shipped with the Sony mechanism, and this is even after all the work that's been done, cleaning it and lubricating it and everything. Right, we'll format the disc firstly. So if I format this disc, and this is a working disc. In fact, we'll try it. We'll get a different disc. Right, so unit 1. We're going to go 80 track, double-sided. Missed it. There we go. Format, ultra speed skew, and we're going to let that disc format, and it will format successfully. Okay, so what I've done here is didn't want to bore you with watching discs format. I formatted this disc here, which is a working disc, and this disc here, I formatted that one. And now when I put the first disc that I formatted back into the drive, and I try to get a directory on the thing, I get this write protected or bad sector. So it looks like some sort of head alignment issue, or worse yet, possibly the right head seems to be making the damn thing unreadable. If I power cycle the drive, perhaps it will start to work again. Yes, it does, starts to work again if I power cycle the drive. Okay, so the disc's actually fine. Let's swap the discs again. That one works fine. And I swap the discs again. And then it works fine again. And then I try to make a directory and it goes off into the weeds. And I've had this mechanism apart again and again and again, trying to figure out what's wrong with it. Well, it looks like my work here isn't done yet because it gets more and more interesting by the minute. So this is the drive with the Epson mechanism in it that came from one of my STs, not the Sony one, the Epson one, which appeared to work great and was a good baseline for comparing the other Sony mechanisms. And not only has the second Sony mechanism started to exhibit the same problems as the first Sony mechanism, but the Epson mechanism now appears unable to finish formatting a disk. So, oh God. So dealing with these old floppy drives is just a colossal pain in the arse. It really is. I can't even begin to describe it. So I've ordered a second Sony mechanism that probably, well, it'll probably behave exactly the same way as the other one, so I don't know what on earth is going on. I really don't know. Alright, I think I've found the problem here, and I hesitate to say that because usually when I say I think I found the problem here and then I start to email people saying I think I found the problem and the solution, then the problem comes back. Now initially I had this controller chip, which is known as an AtariAge chip, is an Atari custom chip, in this board, the controller board for this drive, and this is what the client sent over, two of these chips. No reason why they wouldn't work, you would think. And one of them actually died in the other board, so I replaced that with one of the chips that Lenore kindly sent over. It didn't seem to make any difference at all, but maybe there was a secondary issue at hand here. What I did this morning was connect the Sony mechanism out of this drive, and I plugged it into this SF551 here, into the logic board. And initially I was still getting problems until I formatted the discs with this setup, with this mechanism connected to this drive, because this drive works perfectly fine, this mechanism in it, no problem at all. And once I'd formatted the discs, everything was reliable. So I began to suspect, naturally, that there was some problem of some sort with this SF551 logic board. There was something this mechanism didn't like. So in desperation, basically, I swapped the AtariAge chip in here and I put a WD1772 in there instead. But at the same time, I replaced the ribbon cable and the power cable. The power cable's a bit thicker now. Of course, this drive runs on 5 volts. So probably not a great idea to make 3 changes at the same time. But in this case, I don't care, as long as it works. So both logic boards have now got the WD1772. And that's what the SF551 has in it. I've put the 8.333 megahertz crystal back in this board now, because I just wanted to be as close as possible to the logic board on the XF551. The main difference with the XF551 is that one uses an 8040 MCU, and these ones obviously use 8050s. That's all I've got is 8050s. Other than that, and obviously the layout of the board and the routing and everything, they're identical, functionally identical as far as I can tell. So if I put the thing back together, I've got 3 floppy disks. There's one in the drive and another 2, which are formatted, and I'm just swapping them back and forth, copying files to them, making directories. Normally what would happen previously was that I'd try and make a directory and it would hang halfway through making the directory. Let's copy some files again. Star.star test 6. Of course, these disks are formatted with ultra skew, and we've got the ultimate 1 megabyte high-speed SIO driver in here, so everything is working pretty quick. So there we go, no problems there. Those files are copied fine. So if I eject that disk, this is where things usually fall apart, or did before. Oh. And we do a directory on here. And there we go, it's still reading, so let's make another directory there, test 11. See if it fails. It didn't, so let's copy all the files in the root directory to test 11. So as far as I can tell, that looks reasonably good. So there you have it. It seems to work now, and I think it's just been a matter of a few little sort of ambiguous things that had the silk screen problems, which, as I say, are quite understandable, of course, on a new design like this. Some parts in the bill of materials, there was a couple of substitutes. We weren't absolutely sure whether they were going to be correct and work properly. It was just lots of questions. So it's taken a long time, but of course it's been a learning experience. I've got plenty of practice at reconditioning drive mechanisms now. And they did need reconditioning, because especially the eject mechanisms on these things, when they're not properly lubricated, they get very sluggish. Now the thing spits the disc out quite nicely. It's interesting when you're trying to troubleshoot something and you've got all these different points of failure. You wonder, is it the CPU? We had I noticed another problem with the jumpers on the EPROM. I'd sort of intuited that back to front. Thought that operating system 1 was in the lower half of the EPROM and operating system 2 was in the upper half. Apparently it's the other way on. We had the problem with the jumper for the CPU. That was labelled backwards, so that threw me as well. And then we had these AtariAge chips. Now the fact that one of the AtariAge chips just died spontaneously the other day when I was testing the other drive, that, I don't know, that seems a bit odd. So certainly removing all possible variables and just trying to be as slavishly accurate as possible with like-for-like parts with when comparing it with what worked, and what worked was the original SF551 board, seems to have been the way to go here. So I'm going to leave the WD1772 in there. We've got the same crystal frequency, we've got everything just the same as an SF551 apart from the CPU. So now it appears to work, and it works great. I just wish it hadn't taken as long to get to this point, but I didn't really want to do this project. The client would tell you that I had no experience of building these things before. I'd never seen the board before. I don't think I would have heard of the board before. So when you approached me about it, the quote was pretty high because I imagined it would be fraught with problems. I didn't expect to have issues with the drive mechanism. I've still got to have a look and see why the Epson mechanism in the other drive doesn't seem to want to complete formatting now. But that wasn't the drive that was supplied with the original drive unit. So that's on me, I suppose, because of course I snapped the cable on the original drive, didn't I? So but I have ordered another Sony mechanism, so if the now we know the Sony mechanisms can work. If I have problems with the Epson drive, I'll just swap it out and I'll put another Sony mechanism in the customer's drive. So everybody will be happy. And I've found a universal 5-volt power supply, so I can make the client's US power supply. So that's all taken care of. I've just had to order a couple of connectors. So now I know what I'm doing. I've encountered every possible obstacle I think that you could encounter when building something like this. So I hope you've enjoyed this video, and I hope you like this drive. I think now that thing works, when things start to work, your whole outlook on life completely changes. But so if you want one of these, it's not quite such a daunting prospect anyway to build these things now, because as I say, I know exactly what can go wrong and how to overcome the problems, I think. So we're going to get 2 working drives out of this. This is going to be mine. The other one will go off to America. And if you want something like this, I think Lenore Drop Check, as it were, could be persuaded to probably make more boards. I know she's committed to correcting a couple of the minor problems with this board. I think she's going to try and move the power jack in board a little bit so it'll look better at the back. And it's a really nice little unit. It's a really good idea. I can't remember who came up with the idea. I think it was somebody actually approached Drop Check with the idea of doing this conversion, and it's very good. But as I say, beware, because there's multiple different versions of these drives. Some of them have got the long button on the front, and that in itself isn't a problem. But some of them need 12 volts, the older drive mechanisms, and some of them don't have the right power connector on the back, and you're going to be scavenging around trying to find the right power connector. So there's lots to think about. But anybody who's interested in one of these, I'd be more than happy to put them together for you if we have a discussion about it. And I can advise you on what drive you need to send in, or if you're going to buy one. So yeah, I think it's a really cool drive. I know there have been plenty of other SF551 substitutes produced, but this is by far the best looking one. I think this is better looking than the original SF551 actually. It would be nice if we had a red badge there. I mean, it might look quite good. You could just probably trim, you could probably just take an XE badge, cut it at an angle, then put it on there. You wouldn't have a model number on the front, but at least it would have Atari, just without any kind of model number on the side. That might be better, in fact. So I'm tempted to do that. I've got quite a few old badges lying around. Yeah, so imagine if this was just cut off short like that. That would look pretty good. I think I'm going to do that actually. Right, so imagine if that was just cut off like that. That would match pretty well. I might do that actually. I'll just choose a badge that I don't mind missing and cut it off and put it on there. I think it looks better. So I hope you enjoyed that video. There's the drive still working, and yeah, if you enjoyed it, give it a like. If you didn't enjoy it, you know what you can do. I mean, you know what to do. And thank you to all my patrons. I really appreciate it. And if we've got I can't remember if we've got any new ones this month, but if they are, they'll be on the screen as I speak, along with all the other patrons. Yeah, so if you're interested in something like this, drop me a line or leave a comment under the video. Or you can get in touch with DropCheck. As I say, she's making a couple of amendments to the board design. I can't see any future build being quite as tortuous as this one, because now I know what I'm doing, I know what to expect, and I know all the right parts to use, basically keeping it as close to the SF551 spec as possible. I've got a little bit tunnel vision with this project because it just became so incredibly frustrating, and probably a lot of it was my own ineptitude. The more stressed out you get with stuff, the more silly mistakes you make. But never mind, it's done now, and now I've got to go away. After this video is done, I've got to go away. I might be quiet for a couple of weeks because I've got a ton of work to do, and I have to apologise in advance for people who had computers lying around here for weeks on end. I am getting to it. There's 2 computers ready to go out. I was waiting for some parts. The parts are here. I've got a HDMI adapter that somebody was waiting for. That turned up yesterday. So there's no real excuse now other than having too much to do. As I said before, this is a one-man operation and I can only do so much. But I really wanted to get this video done because I think this is really cool. Obviously I'm feeling much better about it now that I've overcome the problems, and I can see how nice it is. I would have really enjoyed having one of these back in the day. But anyway, yes, so that's enough waffle, and thanks again for watching, and I will see you in the next video, so bye bye for now.